We're done. So to start things off, I just want to do a review on what volume actually is. What is volume?
The whole it takes up to fill up a space.
Yeah, like the sum of all of it, or how much it takes to fill the whole space. Reese, Luke. It's how much it takes to fill it up, right? How much space it takes. Different ways to look at it. How much the shape takes up. I should say how much space. And so how much space? Yeah, so like when you're talking about volume, it's like how much area, like area is just the outside. So volume is how much room it actually needs to exist, right? Like how much space it's taking up. And that's not like a technical definition, right? Like I'm not giving you the technical definition. I just want us to have an understanding of what the heck's going on. So when I say calculate volume, you understand, all right, I'm trying to fill out this whole thing. Yesterday what we did was we took shapes like prisms and we would find the area of just the bottom and then we'd multiply it by the whole height of that prism. So then we said that's how much space it's taking up.
This one doesn't have height.
Right. So this is going to be more of a problem because we're doing spheres today. And spheres don't have like a nice base to go off of. They just don't. So when it comes to a sphere, we don't have that much choice other than just working with the formula that it gave us. So our volume for a sphere formula is on your formula sheet. It's 4 pi r cubed divided by 3. It's just the formula.
Cubed?
Yeah, it's r cubed. So to the power of 3.
Times the radius 3 times.
Yeah. So if the radius is 2, it'd be 2 times 2 times 2.
Oh,
yeah.
Is the full the radius?
No.
And then you have
That's
to
just part of the formula.
Then you have to divide it by 3.
Yes.
The radius. Imagine a cubic feet.
So if we go to calculate this first question, the volume would equal 4 times pi, and the radius is 8, and that's cubed. For those of you who don't have a cubed button on your calculator, that means 8 times 8 times 8. That means 3 eighths. When you put that in your calculator, you're going to get some big numbers for these spheres. That's what I noticed when I was doing this. So 8 to the power of 3 times pi times 4 divided by 3, you get an answer of 2,144.7 inches cubed. It's a big sphere. I don't have any tricks to help you logically get through a sphere. It's just straight up, what's the formula? Do the formula. Can be good. Maybe you like doing it like that. Or maybe you're someone who can visually see, so maybe that's a little harder for you. Just kind of depends on your preference. We've got a few more here. The sphere should go quick because we don't have much choice. Yeah, for sure. So this sphere. Yep, sorry. Is that good? Right there?
Yeah.
So this sphere down here, I already did divide by 3.
Jeez, that's a lot.
It's a lot.
I thought you were going to divide it by 3 and it's going to...
No, it's big. So the volume of the sphere is 4 pi r cubed divided by 3. We go to put those numbers in. That means the volume is 4 pi, and r is not 1.4. Right? That's the only trick they can throw at you. It's 0.7. Perfect. You have to divide it by 2 to get the radius of 0.7. So you have 4 times pi times 0.7 to the power of 3 divided by 3. 0.7 to the power of 3 times pi times 4 divided by 3. You get 1.4, and that's meters cubed. I remember we described volume as being cubed with an exponent 3.
What's 18? No, I got that wrong.
You got that wrong?
No, I did.
Did you divide by 3 at the end? Or do you already know what you did?
Oh, I divided by 2. Yeah,
I mean, it sucks because it's hard to picture what you're really calculating, right? Like that's what I don't like about spheres. I can't be like, oh, I know what I'm calculating. With all the other shapes, I at least had logic to it a little bit. I was like, okay, here's the base. It's a pyramid, so I need to divide by 3 because it's a third of having a cube. This is kind of, you're a little stuck. All right. There's another one there. I recognize right away that it's a sphere, a ball. So I need to go with my formula. V equals 4 pi r cubed divided by 3.
What's that called when it has a circle in the middle? What's that one called?
Like this right here?
Yeah.
That would be the circumference. Yeah. So like all the way around the circle is the circumference. For us, they told us that the diameter is 18. So remember that's not our radius. So we have to divide that number by 2 to get that our radius is 9.
If it's a sphere, will it always have that circumference line?
No. Sometimes it'll have the drawing there, sometimes it won't.
But how do you know if it's a sphere or it's a circle?
I think just by... Actually, that's a good point. It probably will. It'll probably always have it. I've never noticed it before, but now that you say it, it'll probably always have it.
Wait, how many decimals should I do?
Just one. So if you look at that, you punch that in your calculator. 4 times pi times 9 cubed. Divide your answer by 3. You get 3,053.6 inches.
Did we get a formula sheet for volume?
It's the same one. So the formula sheet that I gave you before had like a column for surface area and then a column for volume.
Oh, I can see that.
And I probably shouldn't take credit for those formula sheets. That was Miss Childs. She got us out of that jam. There you go. All right, last sphere. Yep. I want you to try the last sphere on your own. So go ahead, calculate it. I'll throw the answer up so you can check to see if you're right or wrong. You're just following the formula. So it's basically punching in the formula, making sure it's right. Cones kind of present us with the same problem where it's hard to visualize. But what you're going to do is you're going to calculate the surface area of the bottom, which is what we were doing before. And then you're going to multiply upwards to fill this entire thing. But then you have to divide because that's not a cylinder, right? A cylinder would be just circle times height. This is a cone. So we're going to do a circle on the bottom times the height of the cone. But then we have to divide by 3 because a cone fills up a third of what a cylinder would be. Kind of like what happened when we had that pyramid problem. The pyramids were a third of a prism. Cones are a third of a cylinder. So we're doing the exact same situation. The formula, if you have it, is pi r squared, which is the circle on the bottom, times the height divided by a third because it's not a full cylinder, it's a cone. That one's a little bit more logical, a little bit better than the sphere. Yep. So it's pi r squared, and that's from the formula. And that's because that does my area of the circle on the bottom.
What the hell? Polygon is confusing. What's Anch?
Yeah, wait, I get there. Which one are you looking for, Arla? Close the one on. So for us, when we go to do this, we want to go volume equals pi. R is not 14. We have to divide that by 2 to get 7. So it's pi times 7 squared times a height of 18. Divide by 3. If you put that in your calculator, so we have pi. Yeah, that's fine. Yep.
Why is pi so important for surface area volume? What does pi do?
It's important for circles. Pi is like a perfect ratio that will compare like the around your circle to the diameter or to the radius. It's just natural. It's just no one invented it. And that would be feet cubed. I got you. Nobody. Can't invent it. Someone discovered it. I don't know who discovered it though. Okay. No, you don't invent a number. You discover a number. Numbers always existed.
Yeah, but I'm sure someone had to invent numbers.
Imagine if the person got the numbers wrong.
Everything was wrong. Things I want you to take note of on these cones. The height that you use. You must use the height from the middle to the top, not the slant height. All right, remember questions before when we were doing surface area? They gave us slant height. They'd be like, oh, the slant height over here is 13 feet. Volume uses the slope from the middle to the top, not the slant height. Right? Height in the middle, not slant height. Yes, you can. Okay, we look at this question. This is an example where they give us slant height and height, so you need to know which one's which. You want the height from the middle to the top. Don't use the slant height. Yeah, Haley. Oh, that's a good question. Why did I do this? Why did I put a cube here instead of a square? That's a good question? Okay. The reason why is because we had feet times feet, which would give us our squared, but then we times it by height, which is times it by another feet. So it is feet times feet times feet, which is why it's feet cubed. That's a really good question. All your volume questions will always be cubed, just so you know. It'll always be at some point the third dimension. Yeah, it's the same thing. And remember before we used to say that like area was talking about like one little square and how many squares you could fit on the outside? When you're doing volume, you're saying, okay, if I had little cubes. Yeah. This is saying I could fit 923 little cubes in this shape. So that's what volume is doing. Where before we were doing area, that was how many squares I could fit on the outside. Now it's how many cubes can I fit on the inside. Next week. Okay, question 6. Volume equals pi r squared height divided by 3. That means volume equals pi. In this case, r is 3. And height is 4 divided by 3. Notice that I'm not using that slant height. Right? That's kind of how they get you. Same with those cylinder questions last time. No, pyramid questions. You got to use the height in the middle. So if I look at this, that's pi times 3 squared times 4 divided by 3. My final answer is 37.7, and that's meters cubed. That means if I had little cubes that were a meter by a meter by a meter, it would take, I always botch my cubes. It would take 37 of those cubes to fill up that cone. Awesome. Next one. Calculate the volume of that cone. Remember, you want to use the radius, not the diameter. In this case, the diameter is 26. We want radius divided by 2 to get 13 as your radius. You're always dividing that diameter in half so that you get your radius number. Don't just use whatever number they gave you. Sometimes you got to alter it. Volume equals pi r cubed h, r squared, divided by 3. That's pi times 13. This one has a height of 8 divided by 3. If you put that in your calculator,
The calculator does not have the squared symbol, so I'm just doing times 3 with the numbers only.
yeah, remember, squared means times by itself. So instead of 13 squared, you go 13 times 13. And cubed would be times itself 3 times. So instead of 13 times 3, it'd be 13 times 13 times 13. The exponent tells you how many times to multiply by itself. And again, that's feet cubed. Okay, composite shapes is harder, just like it was last, like with surface area. So I want you to solve the rest of the cones in your practice, and then we'll do composite shapes together. We're going to crush composite shapes here. Composite shapes is kind of the same deal as doing our composite surface area, but it's actually easier than composite surface area. So when you're doing composite shape for a volume, try to just picture which images you have, right? In this question, we clear as day have a cube.
Do like one and then do the other.
Yeah. David, up here.
Yeah, we gotta learn.
The cube is clear as day.
Look at the front.
Come on, man. You're disrupting the class.
We're having a conversation. I'm trying to
Yeah,
learn.
and it's disrupting the class. So there's clearly a cube on the bottom and then a cylinder on the top. And what Braden just said, like, can you just do them separate? That's exactly what you do. Just do them separate. Figure out the volume of that cube, figure out the volume of that cylinder, add the two together. With the cube, which I'll do first, I'll do it in blue. I remember that the cube is figure out what the base is. In this case, the cube is 14 times 8. And then I want to multiply by the height of that cube so that I'm filling that entire space. So then times by 12. If you weren't remembering how to do that, you're like, oh, that seems really confusing, Mr. Kennedy. Then look at your formula sheet, and your formula sheet was length times width times height. And that would give you the volume of your cube. When you punch that in your calculator, 14 times 8 times 12, I get 13, you got it, 1344. Then I'm going to add my volume of a cylinder, which I'll do in green. My cylinder, I was doing area of the circle, which we knew was pi r squared. And then times the height of that cylinder so that I'm filling that entire space up. So times 8 or times height. Just like that. 4 times 8. So your formula was pi r squared h.
I'm not feeling between scales and just like coding talking about.
Worst feeling.
But it's worth it.
If you want to just do the formulas, it's on your formula sheet. I just really want you to understand what you're calculating. And by picturing, okay, I'm filling the bottom and then I'm just rising it up to fill up the whole shape, it reminds you what volume really is. So when you see volume one day and it's like, hey, the volume of that thing is this, you know what the heck they're talking about. You put that in your calculator, you got pi times 16 or times 4 squared times 8. 402.1. When you add those numbers together, you get your final answer of 1746.1. And that's feet cubed.
Wait, when you do the square, right? Pretend you sink that cylinder into the square.
Yep.
So you do the square, and then when you're about to do the cylinder, do you just do the label, not the top?
You're thinking surface area. So surface area is when we like sink that down so we can just do the top layer.
Right.
When it's volume, we still do the whole thing. So we still have to do the bottom and times it by that top. So you're doing the label all the way up. Yeah. It's more with our surface area is harder. We had to kind of picture things like sinking it in. With the volume, it's a little bit easier because you can just literally take the two shapes apart. Like if I looked at this question, I would just look at this and go, all right, let's do the cube, which I did in blue. And then I go, all right, now let's do the cylinder. And I don't have to worry about overlaps, nothing. I'm just looking at it.
So it's like you're filling it up.
Yeah, exactly. Honestly, it's easier than surface area. Okay, this one. If you're looking to do this one, and you're looking to do volume, I see a square or a prism on the bottom, which I'm going to do in blue.
Wouldn't 9 be the height?
Of the triangle, yeah.
What is that shape called? That triangle?
That one up top would be called a triangular prism, or you can call it a wedge. That would work too. But I call it a triangular prism.
Or you can call it a tent.
A tent? Yeah. If you call it a tent, I'd be good with that. Honestly, like, I don't know. It's a tent. If I'm looking at the bottom shape, that's clearly a cube. So I'm going to figure out what my bottom is, which is 16 times 4. And then I'm going to multiply it up so that it fills the entire space. So that's times 6. That's length times width times height.
384.
Perfect. So just the cube alone is 384. But then we need to add that top prism. That's the one where we want to figure out the triangle and then multiply that triangle inwards. So for us, I'm going to do it in green. I want to figure out the area of the triangle, which is right here. 12 times 9 divided by 2? Yeah, that's exactly it. So I'm doing this triangle's base times the height of the triangle. So that's 12 times 9 divided by 2. And then we multiply it by if we then fill that triangle all the way to the back. So then you need to multiply it by this side right here, which would be times 4 times height. 108 divided by 2, impressive.
216.
Yeah, 216. 108 times 2. Well done. That's your two shapes separate, right? I did my cube on the bottom. I did my prism on the top. You're adding those together. That gives you a total of exactly, yeah. And that's inches cubed. Right.
Is that him?
Break it into the two shapes, right? And I've watched you now. I've watched you guys do every single shape. You could do every single shape. So if you can calculate the volume of a shape, you can do the composite shapes. That look crazy. It's guaranteed because I watched you do it. So this last one.
It's just like the normal one but divided. Like the first one but divided by 2.
Perfect. So this last one, we've got a cone, right? So we're going to have to do the area of that cone, the volume of that cone down here. Close. It'd be 10 squared. You got to do radius squared. 10 times 10. But I'll do it. I'll write it out. So when we look at a cone, we just do the formula. Yeah, but times pi. So the volume of a cone is pi r squared times the height. Then we're dividing that by 3, right?
How do you figure out the slant? Or how do you figure out the height from the slant?
That one, they gave you the actual up-down height.
Yeah, but what if they don't?
If they didn't and you needed the slant height, then you could turn it into a right angle triangle and calculate it. I won't make you do that. I'll always give you the slant height if you need the slant height.
But we need the height there. What if we just have the slant height?
This one gives you the actual height.
What
15
if it
is from top to bottom. It'll always give you the right height.
Because on the test,
Maybe they'll give you a slot.
there was only the actual height of it, not the slant height.
You know,
And we needed the slant height.
For the test, I'll go check that. That might be my bad. So if I'm doing the volume of just that cone, I'm going pi times 10 squared times 15 and then dividing it by 3. I don't know. Timesing things by pi makes the number ridiculous. 1,570.796 dot dot dot. But that's just the cone. Now you need to do that cylinder that's in that sphere that's in the top. And notice that it's half of a sphere. That means you're going to have to do half of whatever the formula is.
So
Divided by 2, yeah.
So you is it still 10 or is it 5?
Well, for a sphere, we're doing 4 times pi times 10 cubed
for this, would you do 2 times?
divided by 3. If you want, you can do 2 times. Yeah, which is why I'm saying half of it, right? So I put the half in black to say it's half of a sphere, but this is my sphere formula.
Divided by 2 after you divided by 3.
Oh, I don't know. You divided by 2 after you divided by 3, yeah. I want to put that as R, so we know it's R. This means I want half of 4 times pi times 10 squared, or 10 cubed divided by 3. If I put that in my calculator, 4 times pi times 10 to the power of 3. Divide that answer by 3, and then cut it in half. It'd be 2,094.395.
Boy,
Oh no, I forgot this time.
I always ruin it. Me either, man. Do the cone, do half the sphere. When you add those together, your final answer is 3,665.2. And that would be yards cubed.